Before we begin talking about how to convert a number from a scientific notation to a standard form representation, excuse me, let's just talk about some characteristics of both. The easiest to talk about at first is standard form, because that's the normal way you've been writing numbers most of your math life. 123 or 123,000, or even using decimals, 123.5. All of those are numbers that are represented, written in standard form. Well, scientific notation allows us the opportunity to write very large numbers or very small numbers using a little bit of the number plus a multiple of 10. Well, let's just look at an example so we can understand it a little bit clearer. If we take the number 1.23 times 10 to the 8th power, that's a good representation of what scientific notation looks like. The decimal is placed immediately after the first significant digit, moving from left to right. So this number is always between 1 and 10. And connected with that is a multiplier, multiplying it times 10 to some power, in this case 10 to the 8th power. That's what scientific notation looks like as it's written. Again, we use this for very large numbers. For instance, 93 billion is written like that. Well, we can write that number using scientific notation and use a lot less digits. Again, the decimal is between the first number and times 10, and this exponent indicates how far we have moved the decimal. Well, it was here, so we've moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So large numbers, we will see, have positive exponents. And if we can keep that in mind, that'll help us to know whether our answer is correct or not. Well, what about small numbers? What do those look like? Well, let's take a very small number, say 0.00000006. A very small number, 10 hundred thousandths. Well, you get the picture. Well, I can write this number, again moving the decimal to the right of the first non-zero significant digit, as 6.0 times 10, and we've moved the decimal 1, 2, 3, 4, 5, 6, 7, 8, and it is a very small number, so it has a negative exponent. Well, we'll discuss the details in just a minute about how to go from one form to another, but the idea here is for you to see that small numbers have negative exponents and large numbers have positive exponents, and for you to see what scientific notation looks like and what standard form looks like. Now, let's convert some numbers from one notation to another and see how that works. Let's take in standard form the number 123,452.68. Pretty big number. Let's practice writing that in scientific notation. Now we're going to move the decimal starting from left to right after the first non-zero number. So that means we're going to move the decimal to here. So let's write that over here, 1.2. Now all of these are significant digits, so we have to copy those down. Not always the case when we're converting from one to another, but it is in this case. So we've got 1.2345268 times 10 to the, well, let's look. This is a large number, so I know I'm going to have a positive exponent. And I've moved the decimal to this position. It was in this position, which means it's been moved 1, 2, 3, 4, 5 positions. And so my scientific notation for that number is 1.2345268 times 10 to the 5th power. Another example, and we'll limit the number of significant digits here. 93 million, which is in standard form like this. In scientific notation, we start from the left, we move to the right, we look for our first non-zero significant digit, we find it as 9, we will put the decimal there. So I'm going to go ahead and copy this. Now I don't need all of these zeros over here behind the decimal because at this point they won't be significant. I could write them and it wouldn't necessarily be counted wrong, but I'm going to leave it like that because that's the beauty of scientific notation. Well, 9.3 times 10 to what power? Large number, which means I'm going to be looking at a positive exponent. I've moved it to this position. It was way over here, so we've moved it 1, 2, 3, 4, 5, 6, 7 places. Well, let's examine some small numbers. In standard form, 0.0052. 10 hundreds, thousands, 10,000. So 52 10,000s. We're looking at a small number. It is less than 1. So we'll be looking at a negative exponent. Keep that in mind as we check what we do. We're going to move from the left to the right. First non-zero significant number. Put the decimal right after that. So 5.2 times 10. Now notice I don't need to put zeros in front of the 5. 5.2 times 10 to the, let's see, we've moved it 1, 2, 3 places. We've moved it from a small number, so it's a negative exponent, so negative 3. In fact, if you look here, if I'm going to go from scientific notation to standard form, the negative will tell me move it to the left so that I can go back to that number. Now those are just a few rules about how to go from standard form to scientific notation. We'll do a couple of more examples just so that you can get the picture and be on your way to doing this correctly each and every time. 14,000, not too big a number. Moving from left to right, we put the decimal right after 1, 1.4 times 10. How many places have we moved the decimal? 1, 2, 3, 4 times 10 to the 4th power. But the number 0.00014, well, again, moving from left to right, we're looking for that first non-zero number. We found it. We'll put the decimal just after that. So that looks like 1.4 times 10 to the, well, we've got a small number. We've moved it here. We've got to get it back, and we're moving in that left direction. So again, everything about the number line tells us it's a negative number. So 1, 2, 3, 4. So we've moved it a negative 4 places. Now let's see if we can go in reverse. If I have 1.5 times 10 to the 3rd, that tells me I've got a large number on my hands. It also tells me I'll be moving the decimal to the right. Since my number line, positive numbers are on the right, negative numbers move toward the left. So 1 and 5, I'm going to move the decimal from here to this place. I've got to move it 2 more places, so I'm going to put zeros to fill those in. And there's my decimal. Put the comma, which is a traditional standard form application. Large numbers take positive exponents. Well, let's look at 1.5 times 10 to the negative 5th. The negative tells me I'll be moving the decimal to the left. Tells me I'm going to wind up with a small number. So we'll write 1 and 5. And the decimal was here. I'm going to move it 1 place. Then I have to use some zeros to fill some spaces. 2, 3, 4, 5. So we're moving it from here. 1, 2, 3, 4, 5. So 1.5 times 10 to the negative 5th is equal to this very small number. I hope that helps, and wish you the very best of luck in changing numbers from a scientific notation representation to a standard form. Have a great day.